We're going to go into our trig unit, and before we start talking about the new types of trig, we want to review what triangle trigonometry is. So I'm going to go ahead and just give a brief introduction, and then we're going to go ahead and get started. So the first question on here is, what is trigonometry? So, and I'm going to just expand this out so I can type it for you. Trigonometry is a branch of math that studies the relationship involving lengths and angles of triangles. Famously, right triangles. So trigonometry is a branch of math that studies the relationship involving lengths and angles of triangles. When I'm talking about length, I mean sides. So sides and angles of triangles, okay? So that's what trigonometry is. So now it says, when given a right triangle, I can use trigonometry to find what? So when I'm given a right triangle, I can use trigonometry to find what? I can use it to find missing sides. I'm going to type because my stylus is not the best. I can use it to find missing sides and missing angles. So that's what I would use trigonometry for when I have a right triangle. So if I draw a right triangle, and I need to find the lengths of sides, or I want to find missing angles, I can use trig. How I use trig is I always focus on one angle other than 90 degrees, and I usually call it theta. And theta is a Greek symbol, and it's just an O with a line through it. So that would just mean theta, and that's usually what I represent to represent an angle. So theta, and then I have relationships between the sides. I have ratios. So if that's theta, my opposite side is here, so I'm going to give it an O. My adjacent side means next to, so that's going to go here. And my hypotenuse is always across from the 90-degree angle. Okay, so, and I label O, A, and H because there's specific ratios and specific relationships among those sides, all surrounding a specific angle. So if I were to actually have my angle up here, right, O and A would be switched because that would be opposite and that would be adjacent. So that's why we always have to focus on one angle to be able to get my opposite side, my adjacent side. My hypotenuse is always my hypotenuse because it's always across from my 90-degree angle. So we have relationships among those specific sides, and we named them sine, cosine, and tangent. So the sine ratio, sine of x or sine of theta, depending on the angle that you're using, equals opposite over hypotenuse. I'm just write hypot. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So remember one way we use to remember sine, cosine, and tangent is by SOHCAHTOA. So how I write SOHCAHTOA is like this. So, ka, to, and I write it in this format because I remember it goes O over H, A over H, O over A, sine, cosine, tangent. It makes it nicer for me to visually see than if I just write SOHCAHTOA straight across. Okay? So we go ahead and we keep going. Let me just scroll all this fun stuff up. This year, we're going to also study the reciprocal functions, cosecant, secant, and cotangent. So remember in math, what does reciprocal mean? Well, reciprocal means you just flip the fraction. So the reciprocal of 2/3 would be 3/2. So cosecant, its reciprocal is from sine, so that's the reciprocal. So cosecant, instead of opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Secant is the reciprocal to cosine, so that's going to be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which is adjacent over opposite. You really have to have these memorized. If this is not memorized, it's going to make this just a little bit more of a nightmare for you. So now let's go ahead and let's start figuring out some of these problems. So if we take a look, sorry, hold on, computer malfunction. Examples. So I want to find all 6 trig functions of angle theta. Notice I don't have an angle theta in this triangle, so I'm just going to draw one right here. So I'm going to label O, A, and H. So 3 is opposite, H is my hypotenuse, and this side is my adjacent side. My adjacent side I don't have a value, so if I give you 2 values on a right triangle, how would I find that value right there? Well, I have to do the Pythagorean theorem. So I would do x squared. Sorry, my stylus is the worst today. X squared plus 3 squared equals 5 squared. So I have x squared plus 9 equals 25. So now I have x squared equals 16. So x is 4. So I can erase where x is, and I can put a 4 there. So now I can do all my 6 trig functions because I have all 3 sides of my triangle filled out. So sine is opposite over hypotenuse, so O over H, so that's going to be 3 over 5. So if sine is 3 over 5, well, what's cosecant going to be? 5 over 3. What's cosine? Cosine is adjacent over hypotenuse, adjacent, which is 4, over hypotenuse, which is 5. So secant is the reciprocal of that, so it will be 5 over 4. Tangent is opposite over adjacent, so opposite is 3, over adjacent is 4. And since cotangent is the reciprocal of tangent, it will be 4 over 3. If you go ahead and you look at number 2, I have 2 sides, and in order to find my third side, I have to do the Pythagorean theorem, so I'm going to erase this so I have more work. If you want to go ahead and label O, A, and H, you can. If you don't need to label O, A, and H because you have it, then that's great too. So now I'm going to do the Pythagorean theorem to find x over here. So I have x squared plus 12 squared equals 13 squared. It'll let me write. So I have x squared plus 144 equals 169. So I have x squared equals 25. So x equals 5. So I can erase that x, and I can put 5 here. So now I'm good to go ahead and fill out my ratios. So cosine of theta is opposite, which is 5, over hypotenuse, which is 13. Cosecant is the reciprocal, so 13 over 5. Cosine is adjacent, so 12 over hypotenuse, which is 13. So secant is the reciprocal, so it's 13 over 12. Tangent is 5 over 12, opposite over adjacent. So cotangent is 12 over 5. So you're going to go ahead and you're going to do number 3 on your own. And if you look at number 3, notice the symbol's not theta. See that symbol right there? That's another Greek symbol. That's alpha. Alpha. is that simple right there. Kind of looks like a fish. So you got alpha. Okay? So go ahead and pause this video, do number 3 on your own, and then unpause it, and the answers will be on the screen. The answers are on the screen, and one thing I want you to notice is that 2 and 3 were the exact same problem, but the relationship, the location of the angle was in different spots. So what do you notice between these answers here and these answers here? Well, I notice that sine of theta is cosine of alpha in the other one, and cosine of theta is sine of theta in that one. So that's where it gets us into what's talking about a cofunction. So cofunctions it says complementary angles are 2 angles that add up to equal 90 degrees. Because the 3 angles in a triangle add up to 180 degrees, the 2 acute angles of a right triangle will always be complementary. So since all 3 of these angles make 180 degrees, since this one's always 90, that means these 2 have to also add up to make 90, which means these 2 angles are always complementary, which means they add up to equal 90. So another thing that we want to put down is we want to say cofunctions of complementary angles are equivalent. Cofunctions of complementary angles are equivalent. So if I go through and I label each of these sides A, B, and C, in order for it to be equivalent, what I mean by that is sine of alpha is opposite over hypotenuse, so that's A over B, right? That's the same thing as cosine of beta. That symbol there means beta, because cosine of beta would be adjacent over hypotenuse, which is still A over B. And we can also say tangent of alpha is opposite A over adjacent B, and that's the same thing as cotangent of beta. Cotangent is adjacent A over opposite B. So these are just a couple examples. They're not all the examples of what cofunctions look like, but that's just showing you that cofunctions of complementary angles are equivalent. So now if we go ahead and we start solving some problems, I'm going to do a couple of these, and then the expectation is for you to do the rest. If we look at this one, it says, let theta be an acute angle of a right triangle. Find the values of the 6 trigonometric functions of theta. So I'm given sine equals square root of 2 over 2. So I have to draw a picture. And I need to put theta somewhere. I can either put theta here, or I can put theta here. It really doesn't matter where you put theta, so I'm going to put it here. No matter where you put theta, you're going to get the same answer. So now sine is opposite over hypotenuse. So the numerator is the opposite value. The denominator is the hypotenuse value. So opposite, square root of 2, hypotenuse, 2. So now this is just like those problems on the other side. How do I find this missing side? Call it x. I'll have to do the Pythagorean theorem. Oops, and I just totally missed. Unscroll that up. Let's fix that. Sorry. So I have x squared plus the square root of 2 squared equals 2 squared. So I have x squared plus 2 equals 4. X squared equals 2. X equals square root of 2. So I can replace x with the square root of 2. So now I'm good to go ahead and fill out my ratios. So now I can go ahead and fill out all my ratios. So sine we already were given is the square root of 2 over 2. So cosine is the square root of 2 over 2, adjacent over hypotenuse. And tangent is the square root of 2 over the square root of 2, which is 1. So now let's do the reciprocals. So the reciprocal of 1 is just 1. That's easy. If I do the reciprocal of 2 square root of 2, so that's going to be 2 over square root of 2. I can't have a radical in the denominator, so I have to rationalize that. Square root of 2 over square root of 2. So that's going to be 2 square root of 2 over 2, which is a square root of 2. And then cosine, same thing. If I will do the reciprocal, that's going to be 2 over the cosine of 2, which is exactly what I have here, which will just be square root of 2. So let's go ahead and let's look at the next one. It says cotangent of theta is 8 over 5. So draw a right triangle. Put theta wherever you want. I always put it down there. It makes my life easier. So tangent is opposite over adjacent. So cotangent is adjacent over opposite. So 8's adjacent and 5 is opposite. So now I'm going to do the exact same thing to get my hypotenuse. A squared plus b squared equals c squared. So I have 89, 64 plus 25 equals x squared, square root of 89 is my hypotenuse. So now I'm good to go and write all my ratios. So sine is 5 over the square root of 89. So 5 over square root of 89. Gotta rationalize it. Square root of 89 over square root of 89. So I have 5 square root of 89 over 89. Cosecant, it's going to be easier to go back to the drawing board. Instead of opposite over hypotenuse, it's hypotenuse over opposite. So square root of 89 over 5. Cosine is adjacent, so 8 over hypotenuse, square root of 89. So rationalize the denominator. So I have 8 rad 89 over 89. So now I'm going to flip it to do secant, or just go back to the drawing board over here. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, so square root of 89 over 8. So now let's do tangent. Tangent is opposite over adjacent, so 5 over 8. Cotangent is already given, 8 over 5. So one more type of example when I'm given a point. So when I'm given a point 6, 8, so let's think about that. If I make a coordinate plane and I want to plot 6, 8, I'm going to go over 6, I'm going to go over 6, and then I'm going to go up 8, right? So notice if I connect that to my origin, I get a right triangle. So now I can put theta there, and I do the exact same thing I've just been doing. So 6 squared plus 8 squared, so 6 squared plus 8 squared is 100, the square root of that, so that's 10. So now I'm going to just fill all of this out. Sine is 8 over 10, which is 4/5. I simplify it, which means cosecant is 5/4. Cosine is 6 over 10, which is 3/5. So secant is 5/3. And tangent is 8 over 6, so 4 over 3. And cotangent's 3 over 4. So if we go and we do number 2, again, if I draw a coordinate plane, I'm going to go over square root of 11. And since it's -3, I'm going to go down 3. And now I connect that with my origin. Here's my right triangle, my right angle, so theta is always connected where the origin goes. So now I got to do Pythagorean theorem. Square root of 11 squared is 11. 3 squared is 9 equals x squared. So I have 20 equals x squared. So I have 2 rad 5 as my hypotenuse. So if I go ahead, I'm going to do opposite -3 over 2 rad 5. So rad 5 over rad 5. So I have -3 rad 5 over 10. Cosecant is a hypotenuse, so 2 rad 5 over opposite, which is -3. So -3 just always goes on the top. Negatives usually always go on the top of a fraction. Cosine is adjacent, so square root of 11 over hypotenuse, square root 2 rad 5. Rationalize the denominator. I have square root of 55 over 10. Can't do anything else with that. Cosecant, nope, I already did cosecant. Secant is is hypotenuse over adjacent. Rationalize the denominator. So I have 2 rad 55 over 11. Tangent, if I erase some of my work here so I have more space. Tangent is opposite over adjacent. So tangent is opposite, which is negative 3 over adjacent, which is square root of 11. So now I have to rationalize the denominator. So I have negative 3 square root of 11 over 11. So then cotangent is adjacent over opposite. So negative square root of 11 over 3. And I'm done. So the last two problems are for you to do for homework. If you want to check your answers, they're on Google Classroom. And I hope you all have a great day.